All right. This video is going to talk about the law of sines and the law of cosines. Now, SOHCAHTOA, which we've already talked about previously, is specifically used for right triangles. Law of sines and cosines is how we solve for missing sides and angles for non-right triangles. So in the box here, we have our law of sines. A couple things I want to point out. When we're looking at our triangle, our lowercase letters always represent the sides. The uppercase letters are representing the angles. And notice that angle C has side C across from it, angle A has side A, angle B has side B. So that's the relationship here. So you need to know that with the law of sines, we're basically matching up angles and their opposite sides. Now, the reason that there's two formulas here is because typically you want to put what you're solving for on top. So if I'm solving for a missing angle, I would put my angles on top. If I'm solving for a missing side, I'm going to use this one instead and put my side that I'm looking for on top. It just makes solving for that variable a little bit easier. But really, it's just a ratio here. It's saying the ratio of the side divided by sine of its opposite angle should be same for each pair of angles and sides. So typically what we're looking for here is we have two angles, we have one side, we're looking for a fourth side, or we start with two sides, one angle, and we're looking for a second angle. Okay, so we've got two examples here. Right, in this first one, I like to just start off by figuring out what pairs of sides and angles I have. So I have angle of 52 paired up with x, which is the side we're looking for. And then we have this angle of 34 paired up with a side length of 10. So that's good. We have two pairs. Right, two pairs of angles and their opposite sides. So since I'm looking for a side length, I'm going to put my side length x on top. So I'm going to be using this formula right here. Sorry, I didn't mean to move everything around there. Okay, we're going to use that bottom formula. And if you use the top one, it's fine. You're not going to get the wrong answer. You're just going to have to go through a few more steps to actually get your answer. So the way I like to set this up is we're going to put x, which is what we're looking for, over sine of its angle, right, its opposite angle. Right, that ratio has to be the same as the other side that we know divided by sine of its opposite angle. Okay. Now to solve, since we have x being divided by sine of 52, we obviously have to multiply both sides by sine of 52 degrees. So what we end up doing here is this calculation. 10 times sine of 52, all divided by sine of 34. Okay? And when we do this, we find that our side length is 14.1. All right, for this second one, I'm going to do the same thing. I have an angle and its opposite side. And then I have another angle here, but I do not know its opposite side. The only other side that we have, let me erase this. The only other side that we have is this one right here, and we really need to know what this opposite angle is. So what we can do is we know that a triangle has 180 degrees. So what I can do is just subtract away the side, or I'm sorry, not the side lengths, the angles that we already have to find what angle would have to be left inside there. Right? So we would find that this angle has to be 29 degrees. And again, the reason that we had to do that is because we need pairs of sides and opposite angles. Okay, so now we can actually go ahead and set up our ratio. So just like last time, I'm going to put what I'm looking for on top, x, divided by sine of its opposite angle, and that should be equal to our other side that we know, divided by sine of its opposite angle. Okay? And just like last time, to actually solve for x, we have to multiply by sine of 110. So this is the calculation that we end up making here. Okay? So we end up with x is about 36.8. So that's the law of sines. Now, on the next page here, we're going to look at the law of cosines, which is similar. Like, it does the same kind of thing. It helps us find missing angles, it helps us find missing sides, but it's a different formula and it's a different relationship here. So the way that I always think about this is side C is always going to be the side that we're looking for, and angle C is always going to be the angle opposite of the side we're looking for. Or if we're looking for angle C, side C has to be the one opposite of it. A and B really don't matter for this formula. It's just the other sides that we have left. So the difference here is with the law of cosines, it utilizes 3 sides and only 1 angle, whereas the law of sines uses 2 sides and 2 angles. So it's just a slightly different relationship here. Okay. So let's look at an example and kind of talk through how we would think about this. So what I'm always trying to figure out is what my A, B, and C are. So if this is the only angle that I know, this has to be my angle C, which means that this is going to be the side C that I plug into my formula, right? So this is going to be angle C, because that's the only angle I know. The opposite side has to be side C. And then, like I said, the remaining sides are A and B. It doesn't matter which one is which, so you can choose, totally up to you, which one is which. Okay, it's not going to make a difference when it comes to our calculation here. All right, so let's go ahead and actually set up our equation. So based on the law of cosines, it says that c squared, which we know c is going to be x, is going to be equal to plus b squared minus 2 times a times c, or I'm sorry, times b, not c, times the cosine of angle C. Right, so there's a lot more like calculation that we have to actually make here. Now the good news is I can just square root both sides here, and if I plug this into my calculator, as long as I'm including the parentheses and all of that, it's going to just spit out the number that I need. So when we use our law of cosines here, we end up finding that x would be about 21.28. Right? So it looks more complicated, but it's really not. We're just finding our ABC values, getting them plugged into our formula, and that's really it. Right? Let's look at one where we are using the law of cosines to find a missing angle. So this time, the only angle that we have is the angle that we're looking for. So this automatically has to be angle C, right, so in terms of what we're plugging into our formula, which means that 8 has to be side C, right? It's always the one opposite. Again, A and B don't matter, so I'm just going to choose, right? So let's go ahead and set this up. So this time, we know side C, so when we're plugging into our formula, it's going to be C squared, which is 8 squared, equals A squared plus B squared minus 2 times A times B times cosine of C. And this time, that's what we're actually looking for. So this is going to be a little more complicated because x is inside of cosine, and there's a lot of operations happening on the right side of our equation. So we have to do a lot of inverse operations to actually solve for x here. So what I like to do is I like to go through and start just squaring my terms. So 8 squared, and then if I do 11 squared plus 10 squared, that gives me 221. And then if I do 2 times 11 times 10, that gives me 220. So I'm kind of just trying to clean it up here. And my goal is to get this by itself. So if this were just 221 minus 220x, we know that we would have to get rid of our 221 first. So I would have to subtract that from each side. So then I would end up with negative 157 equals negative 220 times cosine of x. And then to cancel out our multiplication, we divide. All right, so it's just like algebra 1, solving an equation, trying to isolate something. And I don't even bother really reducing or trying to simplify this fraction here, because at this point, I have cosine all by itself, which is what I wanted. So let's go ahead and just make these positive, right? Negative divided by a negative is a positive. And just like we did with SOHCAHTOA when we were solving for angles, to actually get to x, which is inside of cosine, we have to do inverse cosine to each side. Right, that's going to cancel out our cosine and leave us with x. So what we're doing here is inverse cosine of this fraction. Okay, so we end up getting about 44.5 degrees. Okay. So again, law of sines, law of cosines, the big idea here is that this is what we need to use anytime we are solving for missing pieces for non-right triangles. Have a great day.